Hi, my name is John Paul Raj, and I'm on a mission to make the learning of math fun. So if you're new to this channel, please do consider subscribing. On this particular video, we're going to talk about how to find the equation of the tangent line and the normal using derivatives. Let's start. Some of the key things to keep in mind from coordinate geometry before we jump into questions on equations of tangent and normal are these. One is the equation of a straight line in the point slope form. Okay, so this is the slope. When the slope is given and the coordinates of a point are given, you can write down the equation of a line using this form. This is the point slope form. Y minus y1 is equal to mx minus x1. And the other thing to keep in mind is also that when you have perpendicular lines, because the tangent and the normal are perpendicular to each other, right? So the slopes of perpendicular lines are negative reciprocals. Okay, we keep that in mind. These are ideas from coordinate geometry. Okay, so I'll just keep this here and we look at some questions like these. It says find the equation of the tangent line and the normal to the curve y is equal to x minus 1 to the power of 4 at the point x is equal to 0 and at the point x equals 1. We'll just take one of them and the second one should be in similar forms. All right. The idea to keep in mind is that dy by dx, what does that represent? Okay, dy by dx actually gives us, if you've seen earlier, it gives us the slope, right? It gives us the slope of the tangent. So when we find the expression dy by dx in an algebraic form, that expression actually gives us the expression for the slope of the tangent line at that particular point. So when we plug in x is equal to 0, you're going to get the slope of the tangent line at that value at x equals 0. So we're going to make use of that approach. I'm going to solve this question here. So I'm just going to write this is the first question we're looking at. The equation is, the curve is defined by y equals x minus 1, the whole thing to the power of 4. dy by dx, differentiating, we'll write it differentiating with respect to x, we would get dy by dx as 4 times x minus 1, the whole thing to the power of 3. This is chain rule, times the derivative of the term inside is just going to be 1. Okay, so dy by dx basically is just 4 x minus 1 the whole cube. All right, now at the point x is equal to 0 is where we're looking for the equation of the tangent. So that's where we want to find the slope also. So what we're going to do is that at x is equal to 0, dy by dx, sometimes some textbooks you'll also see this kind of a notation. Okay, dy by dx and there's a bar and then x equals 0. That's basically you're just plugging in x equals 0. So when you just do that, you'll get 4 times 0 minus 1 the whole cube. And negative 1 cube is just going to be negative 1, so that this is going to be negative 4. That's the slope of the tangent at x equal to 0. We need the coordinates of the point. We just have the x coordinate. We need the y coordinate. And to do that, we just simply put x equals 0 into the original equation. Okay, so the coordinates of the point y at 0 is going to be 0 minus 1 to the power of 4. And negative 1 to the power of 4 is just going to be 1. So the point we're looking at is 1, 1. And the slope m is negative 4. This is for the tangent, right? So we can then write down the equation of the tangent using that point slope form. Okay, you can say the equation of the tangent is y minus 1 equals m, which is negative 4 x minus 1. Okay, and then when you can simplify this algebraically to say this is just y equals a negative 4x plus a 4 plus a 1, giving you y equals a negative 4x plus a 5. That is the equation of the tangent. Okay, what did we do? We just differentiated y, okay, dy by dx, and that will give us the expression for the slope of the tangent. And they'll have given you some point where you need to find the equation of the tangent at that value of x, at x is equal to 0. For in this case, we just substituted x equals 0 in that expression for dy by dx, and that's the slope of the tangent line. Once we found the slope of the tangent line, sometimes you're given the coordinates of the point, sometimes it's not given, you're just given that x value. If you're only given the value of x, plug into the equation of the curve, find the value of y, then you can find the coordinates of the point. So we need the coordinates of the point and the slope of the tangent, and then it's simply substituting into that expression for the point slope form, and you can find the equation of the tangent. This is the equation of the tangent. To find the equation of the normal, we make use of the idea that the tangent and the normal are perpendicular to each other, right? So we can say slope of the normal, or gradient slope of the normal, is going to be equal to a 1 over 4. If the slope of the tangent is a negative 4, the slope of the normal should be a negative reciprocal, so it's just 1 over 4 at the same point, okay? It's at the same point, that is 1 comma 1. So we just say equation of the normal would then be y minus y1, which is still 1 comma 1, right? Y minus y1 equals 1 by 4 x minus 1. Okay, and when we simplify that, what are we going to get? We're going to get y is equal to 1 over 4x minus 1 by 4 plus 1. And when we simplify that, we will get this as x plus 3 over 4. Okay, x plus 3 over 4. This is going to be the equation of the normal. All right, so the only change is that we just make use of that idea from coordinate geometry, which says that the slopes of perpendicular lines are negative reciprocals. Cool. Let's take a look at another kind of question. Okay, so this was a question. I just said we'll do one part because it's just going to be repetitive. Let's look at another kind of question where it says the line y equals mx minus 48. The line y equals mx minus 48 is tangent to the curve y is equal to x to the power of 4. Find the possible values of m. Okay, so they've already given us that this line y equals mx minus 48. The slope is not given. Slope of the tangent is not given. It's just denoted as m. The y-intercept is given to us. That's tangent to the curve y is equal to x to the power of 4. So the same idea, dy by dx gives us the slope of the tangent. So we can just say dy by dx is going to be equal to 4x cubed. Correct? And we know that dy by dx gives the slope of the tangent, and this is the equation of the tangent. It's tangent to the curve. We need to find the values of m. So we can say that this m, all right, this particular m, at some value of x, m is equal to 4x cubed. Correct? Also, we have to make use of the idea that the line, because it's tangent, you know, whatever the curve is, this is x to the power of 4, right? So the curve is somewhat a flattened parabola, something like that, okay? So if I have the x-axis and the y-axis this way, so it's something like that. And the tangent to this particular curve, all right, so if what color should I use? Let me just use this color. All right, so the tangent, let's say we were just drawing the tangent. There's a common point, right? The tangent and the curve share a common point. They become equal. So the y value of the tangent should be equal to the y value of the curve at that particular point of tangency, right? So we'll make use of that idea and say, just going to draw a line here, that at that point, at the point of tangency, at the point of tangency, the y value of the tangent line, which is mx minus 48, right? So mx minus 48 should be equal to the y value of the curve, which is just x to the power of 4. Clear how we got this idea? All right. Now m, we have from this expression out here, m is equal to 4x cubed. Just let's use that, okay? So it's basically 4x cubed times x minus 48 should be equal to x to the power of 4. So we can then simplify that as 4x to the power of 4. We can bring that x to the power of 4 here, so that will become x to the power of 4 is equal to 48. Solving that, you'll get 3x to the power of 4 is 48, and which will give us, let's draw another line. This will be x to the power of 4 is basically 48 over 3, and that's basically 16. Okay, so that's x to the power of 4 is 16. We are going to get two values of x. Two values of x. The two values of x are going to be plus 2 and minus 2. Those are the two values of x where this condition is possible, and that condition means that, you know, the line is tangent to the curve, and you have this idea that m is equal to 4x cubed. All right, so we need to find the values of m. Remember, not the values of x. So the two values of m would be m is going to be when x is 2, so m1, if I call that the first value of m, 2 to the power of 3, which is 8. 8 times 4 is 32. The second value of m, if I call that m2, it's going to be 4 times negative 2 to the power of 3. That's a negative 8 times 4 is a negative 32. Okay, so those are the two values of m that will satisfy these conditions. that y equals mx minus 48 is a tangent to the curve, and those are the possible values of m. M is equal to 32 and m is equal to negative 32. Okay, so what did we do? We just use the idea that the derivative, when you differentiate y is equal to x to the power 4, you get 4x cubed, and then we got that m. Remember, we said that that equation was already given to us, that y is equal to m. So we equated m is equal to 4x cubed, and then using the idea that, the tangent and the curve, they share the same point, right? There's one common point, which means their y values will be equal. So y equals mx minus 48. We equated mx minus 48 to the equation of the curve, and then substituting the value of m as 4x cubed, you solve and find the value of x, and then we ended with the value of m. Now, if you found this video useful, make sure you like, share, and subscribe to this channel. I'm going to see you all in the next video.